Thank you, and thank you for the invitation to present this project. Maybe quickly before we dive in, just a word about who I am and my colleague who will help me present this. So my name is Lars Halvorsen. I'm one of the managing partners of edenceHealth. I'll come back to who edenceHealth is in a moment. So maybe Jared, just quickly who you are here as well.
So I'm Jared Houghtaling. I'm a data scientist at edenceHealth, and I have a background in biomedical engineering. And I was one of the technical leads then on this particular LAISDAR project. So I was very closely involved with kind of the technical implementation and kind of the strategy that was employed. So I'll talk a bit about that today.
Okay. Thank you. And then so we're talking about the LAISDAR, federated network of hospitals that will be helped set up in Rwanda. Just a few quick notes on the things we'll try to cover. I won't go through these, but just to give you an idea of the outline. A couple of words just before we start on that part, who we are, so edenceHealth. So we're edenceHealth. We're a part of the team you see here. You're part of the team that was in Rotterdam recently. So yeah, we're an EHDEN SME. We are based in Antwerp, in Belgium, and we have worked with a number of EHDEN data partners, but we also do the same kind of, let's say, OMOP CDM projects, data harmonizations for other initiatives. And then one of those is LAISDAR. So I'll give a bit of background on what this project is, how it came about, and who's involved. So the LAISDAR project, LAISDAR, the abbreviation stands for the Leveraging Artificial Intelligence and Data Science Techniques in Harmonizing, Accessing, and Analyzing SARS COVID-2 COVID-19 data in Rwanda. Long word, but that is basically the reason this project was initiated was because of the pandemic, and it was a way to start focusing on, say, follow-ups needed. The intention was, of course, to get a better view on COVID-19, the impact, the needs in Rwanda, so that planning could be informed accordingly. The project is funded by the Canadian International Development Research Centre, together with the Swedish International Development Corporation Agency, and this is part of the Global South AI for COVID program. So the intention or the plan was to set up a federated data network of 15 hospitals in Rwanda. It was set up as a consortium that's led by University of Rwanda, together with the Rwanda Biomedical Centre, and then Ghent University. So those are the main. There are also other parties involved, where our role, edenceHealth, also help design and implement, say, the technical solution. It was launched. The project was launched at the end of 2020, and it just concluded here last month in June. So, like I said, the objective was to use information from the hospital data sets, EHRs, but then extended with data from central national COVID-19 test results, and also from a survey that was done as part of the project. The intention was, of course, to then get a better base for making decisions related to the COVID-19 pandemic. Now, of course, by the time this was in place, the pandemic was no longer the same urgency, if you will, as initially. But this has now, the platform that's been set up and created will be then the basis of other research topics or other initiatives to then look at infectious diseases and other, say, health needs in Rwanda. I'm just going to zoom in on the coverage just to see that in the hospitals and the clinics involved are spread, say, across the nation. So it's with the intention, of course, to have a more geographically representative source of data. So I'm quickly just going to, the approach, of course, a federated data network, where the hospitals were set up as let's say, the data nodes. Yeah, the choice made was to set up these nodes on Mac Mini computers. So basically, we had a Mac Mini deployed at every hospital that had all the necessary tooling on it. The hospitals that were participating had either OpenMRS or OpenClinic GA as their EHR system. So we supported those two source systems. There's a central server that served basically two purposes, both as a central hub, if you will, for the study management, the catalog, the view on the whole network. Plus, it also hosts the two central data sources, basically an OMOP version of their COVID-19 national test results, as well as the results of this LAISDAR specific survey. Then I'll pass it on to Jared to go through the architecture and in more detail.
Great. Yep. Thanks. And I'll just let you know when I need to change the slides.
Yep.
All right. So kind of this is a bit of a visual of what Lars was just talking about with this, of course, the central node as well as the hospital nodes themselves, so the central server and the hospital nodes. So there's really three key components. On the left upper side, you have the source data that's aggregated on a national level related to COVID. That includes testing results for COVID, both PCR and antibody antigen tests, as well as COVID survey data. And this was, I think, a 10,000 plus patient survey across the country that had very specific questions about public health responses to COVID and kind of personal experiences with the COVID response and things like that. That is then indeed aggregated nationally, and then what we did is each hospital had its own Mac Mini, and that hospital would reach out to the central location with a distinct set of patients at that hospital, and the central location would then send back any data, either case or survey, that was associated with that hospital's patients. So that was kind of this interplay between you had each hospital had its own node, and then you had a central kind of augmentation with COVID data. And then on the bottom right here, you have all of the tooling that is at the kind of the Ministry of Health or the central hub level to access an overview of these kind of aggregate values in the various data sources and assess study feasibility and data quality and things like that. All right, maybe you can hop to the next slide here. Indeed. So then each hospital node, kind of zooming in on that central piece, is really an independent kind of Odyssey setup. So it has all of the tooling necessary for executing ETLs, for interacting with the data via the Odyssey tools. It has an Arachne node instance, as well as RStudio with the Hades packages. It has then an Aries indexer, not actually the Aries application itself, but it has the ability to create the index that can be visualized by Aries. And then, of course, key to all of this is this kind of core CDM database, which is in Postgres. And all of this we've deployed using Docker. And so each of these various services is running as a Docker service or Docker container. You'll see at the bottom there, Arachne node has a little asterisk. That's going to kind of reappear throughout. We have the containers are available, but we have not let's say, executed a full test to this point. We're focused still on data quality and kind of study feasibility before we jump into actually running these arachne-oriented executions. Maybe next slide. Okay, and then I presented, for those of you who were at the EHDEN meeting a couple weeks ago, or sorry, the Odyssey Europe meeting a couple weeks ago, I presented this slide and kind of in both a lightning talk and on a poster. I'm not going to go again in too much detail there, but and this kind of summarizes what I was just saying with these various services. What you're seeing on this slide is what is effectively installed on all of these different hospital Mac Minis. And what I haven't mentioned so far is this little cloud symbol that you see in the top right and kind of the bottom middle of that slide. That's a simple MDM. So it's a multi-device management software that we're using to deploy scripts or to automate the deployment of scripts to these machines that then will, like, let's say, initiate the ETL execution, or it'll initiate the quality control process. And we can do that then remotely. And that then allows the Mac Mini to interact with the central server and work like that. So what then this allowed us to do, and what I had presented a couple weeks ago, was we can run these iterative cycles of let's launch the ETL, let's evaluate the quality, and then make changes to that ETL and kind of work in that fashion across multiple sites. And so that was very useful once we had that up and running, to be able to get a very nice view on, let's say, the discrepancies in the data between sites and how we can address that by changing the ETL. What's also shown here is, of course, each site has its own atlas, and I think this was one of the big, say, exciting things for these hospitals to see once they had their Atlas instance up, and it was available on the local hospital network, and they had different people logging in and interacting really with the data in Atlas. And we started with some training on that as well. So it was an exciting kind of moment to see Atlas being used at these independent hospitals. And then maybe just the last bit here on the bottom right is reporting, and we'll have a couple slides on that later. But there's a very much excitement about the idea to generate and stitch together reports of CDM data to be used as kind of quality reporting or quality of care reporting in conjunction with the Ministry of Health. But I'll get into more details of that in a bit. Maybe next slide. Great. I already a bit touched on this. Indeed, there's these two federal or national data sources for COVID, the case data and the survey data. We wrote ETLs for both of these, which I guess is coming on the next slide. But those then exist in the central server location. So those are on a central server hosted by the Ministry of Health. And then we transform that data into its own OMOP instance on that central location, and we use it in an API to effectively filter that data when requests come in from the various sites, so we can then augment the hospital data with this national COVID information. All right, next slides. And then this is the central hub. And so what we have done then is we've set up, and I think Aries is thus far been the most useful for having a network-wide overview, but we have then an Aries, the application itself, so this web application running on the central server, and it's accessing the index files that were produced on each of the hospital node sites that have been then sent from the node site to the central location. And again, you'll see the Arachne server has a bit of an asterisk, but that is also available in the central location, as is our studio with the Hades packages and Atlas. There's an Atlas instance to interact largely with the two COVID databases that are on that central server. All right, I think that's good. And then, so that's the mapping. So Lars already mentioned, but of the hospitals that were included in this, they either had an EHR system based on an open MRS or Open Clinic GAs. These are two open source EHR setups. And what we ended up doing was we wrote structural mapping for each of those, but we used a common ETL effectively. So we have a single ETL code base, and then we have a switch that we can change between the structural logic for Open Clinic GA versus Open MRS. On the semantic mapping sides, because of the relational nature of these database tables, we didn't have, at the beginning at least, a very clear insight into source code description pairs and things like that, which have now become much more clear as we have executed ETLs and we have the arrays output. So we had kind of the first, let's say, low-hanging fruit mappings at the beginning, and we've now since significantly augmented that as we have a better view using arrays on which codes are unmapped and which codes, let's say, on a network level will provide us the quickest gains in terms of frequency coverage, things like that. And then the last point here, I presented a poster where we discussed this idea of generating custom concepts that are integrated together with the OMOP vocabulary tables, and we had to use this application for the survey questions that were sent out and compiled across the country, because of course these survey questions were non-standard. They were also in Kenya, Rwanda, so in the local language, and they were very specific for particular COVID's related topics that don't yet have a standard equivalence in the OMOP vocabulary. So we created custom concepts for those survey concepts, and then every hospital site shares the same vocabulary that also includes those custom concepts. So when it requests custom these COVID concepts or COVID data from the central location and it retrieves it, it has the proper vocabulary references and tables to link with those COVID information. Perfect. Next. All right, so I mentioned already a little bit about the ETL, but indeed we wrote a single ETL code base with a switch depending on the EHR system. It was a kind of a Python backbone with so let's say structured SQL or kind of object-oriented SQL, I should say, embedded in that. The first step of the process was to export or kind of cache data from the source databases, which in both cases are MySQL. And then with that cache data, we then uploaded and began the ETL process in Postgres and Python and things like that from that point. In the middle of the ETL, actually, once the first, let's say, core source data is transformed, the container running the ETL sends a query or actually an API request to the central location saying, I have patients XYZ, and then the central server evaluates that, filters out COVID cases, and sends back a subset of COVID cases and survey results for those patients. And then the ETL completes with that additional information altogether. Yeah, and so then I already mentioned, so we wrote an ETL for the COVID testing as well as for the survey itself. Fairly simple ETLs, both of them, because there were not very many complex concepts that we're talking about here. It was only recording the results of COVID measurements, and then the various survey questions. And of course, the caveat that I mentioned already with the survey ETL is it's referencing custom question concepts, I should say. Most of the answers to those survey questions, we found standard equivalents, but the questions themselves, many needed to be custom. Okay. Now to the Odyssey tooling. So this project would not have been possible without all of the fantastic Odyssey tooling available, and we're relying on this heavily, right? I mean, I think we have the HADES packages, we're using Atlas and Aries and all of these other kind of fantastic tools that the community has developed. And as I mentioned before, each hospital has its own Atlas instance that references its own hospital source data. It then also has the RStudio packages necessary to run the quality checks, and then the HADES libraries to actually run some models or train some models against the data. Similarly, on the central server, you have a central Atlas instance that's referencing the COVID data, which exists as a standalone, and then it also has RStudio with the various HADES packages as well as Aries, the web application, and then Arachne server for kind of future study coordination and execution. All right. For me, what was very interesting is on my second trip to Kigali, it was very clear that there was a lot of excitement around reporting and the ability to take to kind of request a given month, let's say January 2021, and retrieve then a set of predefined either phenotypes or various measures of drugs that were administered or procedures that were done, things that will inform quality of care understanding for a given site. And so what we ended up doing is we used or using kind of Peter Reinbeck's CDM inspection reports as, let's say, a guide or a baseline. We expanded on that using some example reports that are being generated now by hand at these hospitals. And so we combined those two things, and we actually created a report generation tool that the hospitals can use, that then they specify a given month or a given time period even, and it will produce for them a report consistent with what they need out of their templates. And so this is just a very simple test example of what that might look like. And again, this is not at all real data. This is just a bunch of random drugs, but you can get an idea of, you have these tables with which drugs were administered and which times. And this gets more complex as you start to look at stratifying by gender and stratifying by age and disease profile and things like that. So yeah, but I also want to emphasize this is still in the proof of concept phase. So this is, it's in progress, and it's something that we have already the ability to generate kind of preliminary reports, but we've been working on support for a GUI to make it much easier to interact and customize those reports, as well as some additional functionality for what those reports contain in terms of plots and types of information that can be spit out. Okay, quality approach. So this gets back to also what I presented several weeks ago, with the idea here that, and of course, in the very beginning, we used White Rabbit. We produced scans of each of the various data sources, used those to generate both our structural and semantic mappings, as well as we could, of course. And then we have quality checks during the ETL execution. So we have runtime checks. We did things like creating a patient snapshot where we would randomly select several patients and kind of put a side-by-side of their source versus OMOP data that could be then manually reviewed and evaluated for proper logic. And then after the ETL was executed, this should all look familiar, but we launched Achilles and Data Quality Dashboard, and then used the ARIES indexer to effectively create an index of the output of both of those tools that could then be visualized in the ARIES web application. Of course, each of these sites also has Atlas, so the data managers can interact and explore the data, also single patient profiles that you see on the bottom right there with that tool. And at the central level, or let's say the network-wide level, we can also compare quality output across the sources, both in a study feasibility context, but also in terms of like an ETL or a mapping optimization context. And then yeah, that's perfect. And then indeed, as I was mentioning, so the ARIES indexer, it's kind of the last bit that runs. So we run Achilles, we export the Achilles kind of concept specific characterization results, and then we execute DQD, export those checks as a JSON file, and then the indexer kind of wraps all of that up together with any prior releases, and then it actually sends it off to the central server, which then triggers a whole cascade of processes that integrate that ARIES index into kind of the ARIES web application on the central server. So we have, I think within an hour or so, we have from ETL start to having our quality checks available in the central location. Okay, great. And yeah, and then this is kind of where we're at now, or this is what you see when you browse to that ARIES central location. We have, in the moment in ARIES, we have 13 of the hospitals represented. So you'll see that we have more than 3 million patients. In OMOP, we have close to 3.5 million. But there's still one site that had actually a power surge and ended up with a dysfunctional Mac Mini because of that. So we're in the process of replacing that Mac Mini so that we can then integrate it here into the rest of the ARIES results. And then the information from the COVID case we don't yet have in ARIES. but everything else is there, and you can see there's already been several source releases on some of these, which is really kind of limited by how often they're checking in, and they're available and they haven't been shut off and things like that. So that's the current status. That's what we look at in ARIES at the moment. And maybe now I'll hand it back to Lars to kind of talk about what's coming next with LAISDAR.
Great. Thanks, Jared. So yeah, just a few words at the end here on where we are and yeah, what's the plan next. So like I mentioned initially, the LAISDAR project as such concluded at the end of June, but there are ongoing efforts to say find other sources of funding, basically to continue this work. So it's by no means the end of this initiative. So what we have, of course, now is that we have a first version, at least, of these OpenMRS and OpenClinic mappings to OMOP. We have 14 hospitals. There's actually 15 MAC minutes, but the last one wasn't deployed yet. So we have 14 hospitals in scope, except the one that fried, so it needs to be replaced. Like Jared has explained, we have basically a process set up to automate much of this in collaboration, of course, with the local IT and data managers at the hospitals. And yeah, we have also done some initial trainings, both on the, let's say, the more technical deployment aspects, as well as on Atlas. So that's kind of where we're at the moment. So we do expect to be able to continue this work in some context where this platform now hopefully allows other initiatives, other projects to start from. So maybe just a few quick acknowledgements. So obviously, like I mentioned, the Ghent University team, of course, led by Dr. Mark Twagi Rumukisa. The University of Rwanda team, led by the PI, Dr. Charles Ruranga. Then we have, of course, the Rwanda Biomedical Centre team. And of course, all the participating hospitals and their IT and data management staff. The edenceHealth team, obviously, and then the funding agencies and the overall program. So yeah, a couple of I will share these slides, of course, but there's a few like Jared also referred to. We had some presentations on parts of these solutions at the recent Odyssey Europe symposium. So yeah, I'll be happy to share these slides if anyone's interested in those. That's it. So yeah, that's what we had to present. So hopefully that was helpful. And then any questions?